So in this video, we're working through parallel lines and congruent triangles. We're going to start off with the corresponding angle postulate. Again, this is the way the assignment looks. We're reviewing the concepts of parallel lines, and at the end, we started to talk about congruent triangles. So we're going to start off with the first one. That's the corresponding angle postulate. So let's have a look. The first thing that we want to understand is that two lines are parallel when the corresponding angles are congruent. And this is a postulate, so that means we can't prove this. This is one of those cornerstones of mathematics. This is the foundation of geometry. And we need this to be true for everything else to be true also that we know about. So this is not something you can prove, all right? This is a postulate. We have to take this for granted, and we're very sure that this is obviously true, but we just can't prove it. So we want to indicate that the two lines are parallel by adding those little marks. And then what I'm going to do is add in some lowercase letters to help us represent what these angles might be. Okay, and we'll use these to help us figure out what this relationship is between corresponding angles. Okay, we're talking about these angles being congruent. Okay, so two lines are parallel. This is the first idea we're trying to connect. Okay, if and only if. So what that means is that this is a two-way street. Is that if they're parallel, then that means that the corresponding angles formed by the transversal have to be congruent. Alright, so if this is true, the thing in the first box, then this thing in the second box also has to be true. Okay? So it works this way, right? If this thing is true, then this is true. But also, if this is true, then this is true. Okay? So that's the way if and only if works. It pushes us in two directions. So it's like two sentences in one. So it's a very strong statement. It's making a very specific claim. All right. So we need to know that that's true so that we can use these in cases that we want to show that lines are parallel. So what we're going to do is just take a look at the corresponding angles idea and figure out which angles must be equal in measure to the other corresponding angle that we have. And we're going to stick, of course, to corresponding angles in this little list. Okay. So A, I would represent this. This is like in the top left, okay? And E is also in the top left, all right? Relative to this point right here, right, to these vertices, we see that A is on the top left and E are on the top left, so those correspond with each other, okay? The next idea we'll do is we'll go look at the next one, okay? And I see F, for instance. F is on the top right, right? Relative to these four angles right here, F is the one on the top right. It's on the right side of this transversal line, right? That line is called the transversal. Okay, so F must be equal to B then. Okay, those two angles have to be equal to each other again because they're both in the same relative position. So this is what corresponding means. In the same relative position. So B is equal to F. Okay? Now we'll go look at the picture and start to see that we've already used one arc and we've used two. So now this means that we would use three. So C is going to get three different marks. Okay, and C is on the bottom right, so that means that G would also have to have three marks. Okay, so C and G correspond with each other. Okay, the last one that we have is D. Now we don't usually use four marks. So once we run out of three, what we do is we'll put a little tick mark on the arc itself to indicate that those two are equal to each other. So D is equal to H. Okay, again, those are corresponding angles. So this is something that we've done before. I'm going to try to break this down a little bit more slowly in the next thing, so you might be able to skip this part in the case that you're totally clear on what corresponding angles are. So again, this is for those of you that were a little bit confused as to what I just did. So I'm going to try to explain to you what's going on. Okay. Relative to this point, right, we have this side, this line that we're talking about, this transversal line. Okay, we have a few different parts that we could talk about. We have the left side of this line, and we have the right side of the line. Okay, so let's make sure we understand what we're talking about. We're talking about this line, okay? Now, when I talk about them relative to this line and this point, we can now set up everything, okay? This angle, for instance, is on top of the blue line. So I could say that this one is on the top left. This one is on the top right, if you understand what I'm trying to say. Okay? I would call this one the bottom left, right? Because this angle is on the bottom of that blue line. and we can call this one the bottom right, okay? Because this one is on the bottom of the blue line, but it's on the right side of the red line, okay? So this is what corresponding means. This is the idea I'm trying to get, okay? Which one of these angles down here is on the top left, right? This one is on the top left also, right? It's on the left of the red line, but it's on top of the blue line, right? So this other one, we have the top right. And then we have the bottom left and the bottom right. Corresponding, again, means that they're in the same relative position, okay? So the angles that have the same exact word written in them are corresponding. So what I'm trying to say is the top left is equal to the one on the top left. The top right is equal to the other one on the top right. The bottom left is equal to the other one on the top right. I used 2 marks already, so now I have to use 3, right? So I can say that that angle is equal to this one. Okay, so we use 3 marks. And the last one, okay, we already used 3 of them, so now we'll have to do is 1 and put a tick mark on it. We'll put 1 arc and put a tick mark on it, okay? But the big idea is that you understand that those angles have to be equal and that we know what I mean when I'm saying top left, bottom right, and all of that, okay? I always tell my students that the key to not failing questions on parallel lines is making sure that you've mastered this idea, that you're not confused about any of it. I really feel like this one picture captures all of the ideas that we need to solve the real parallel lines problems. Okay, and the point I'm trying to make is that there's only 2 relationships, right? Either 2 angles add up to 180 or they're equal to each other in this situation. So how can I use this picture to help me solve another kind of problem, right? So that's going to be the goal of this little section of the video right now. So I'll put this over here and I'll give you guys another example so we can talk about what I mean. Okay, let's say I got 2 parallel lines. Okay, to indicate they're parallel, again, I need this little mark. Okay, and of course we call this line the transversal. All right, this one that I'll highlight in red that crosses the other 2. Okay, so the line that crosses the other 2, it's called the transversal. So now what's going to happen is we're going to go add some other little numbers in here. We'll add like 130 right here. Okay? Now let's say that I gave you A, B, C, and D, and I told you I want you to find what those numbers are. How can I use this picture to help me solve this problem? How was all of the knowledge contained in this picture? Okay, well, let's start off by looking at the relationship between 2 of them. All right, let's look at these 2. What's the relationship between these 2 angles on the inside? We call those same side interior angles, right? They're on the same side of the red line, okay? So we call them same side interior angles. We also call them consecutive interior angles, right? That was another word I taught you guys. So just understand that we know that the word consecutive and same side are interchangeable. Either one of those words can go there. Okay, so let's look at our same side interior angles. Let's find out what's the relationship between those 2. Are they equal or do they add up to 180? In this case, we should see they're not equal, right? I don't see the same number. I see 2 different numbers, 180. So these 2 have to make a sum of 180. So that means that D must be equal to 50 degrees or I won't get 180. Okay? Well, now let's find another one. How could I use this picture to help me figure out what A has to be, right? Well, I'm going to look at 130 and say, okay, this one is on the top left right here. And I'm going to look in this one and say, okay, the top left, what was the relationship between this angle and this angle? Oh, look, they're equal. Those 2 angles are equal to each other. So that means that A must be equal to 130 because this angle is 130. Okay? Likewise, we should always see that the vertical angles are true, right? So these 2 angles opposite each other have to be the same. So these 2 angles should be the same. So that means C should be 130. Okay, and likewise, these angles are also the same, right? So notice that these 2 have to be the same. So if D is 50, then B also has to be equal to 50. All right, so I hope you guys get my point. All right, B is equal to 50 degrees. So those 2 angles are equal to each other again. And we have this idea of how this picture can help us remember the relationships. Okay, all you have to do is look at the page and try to remember, okay, are these the ones that add up to 180 or are they equal to each other? That's really the only possibility that you have. Okay, so let's get into the assignment and the practice that you guys had to do. So we just covered the corresponding angle postulate. So now we can take a look at some of these problems and understand what we need to do to get the answers. Okay, as I said, in a problem like this, you can look at this shape that I've been mentioning, okay, that if we draw this on one of our problems at the beginning of a test, you can look at this for the rest of your test and this can help you out. So it's really simple to accidentally put a relationship that's false, and so that's why this picture will help you make sure that you're thinking the right way, okay? So we're looking at this. I want to change the question mark to an X, and then we want to figure out what's the relationship between these two same side interior angles. Well, I'm going to circle these two because they're in the same location, right? And I say, hey, these two add up to 180. So that means that these two have to add up to 180 too. So we'll write 78 plus X equals 180. And then you can solve that, and if you do your algebra taking 78 from both sides of this equation, you'll get that X is equal to 102 degrees. So most of these problems were numerical, and just trying to make sure that you guys could develop some reflexes and how to change the values really quick, understanding whether or not they're equal or do they have to add up to 180. So on number 3 right here, what you guys would get is that these are equal. Those are two corresponding angles. And so that's kind of what I wanted people to write on every problem. Would have been here, you would write corresponding angles, and you write X equals 76, and move on to the next one. Okay? This next one, we have vertical angles, right? And so 95 and 95, those would both be equal. Okay, we'll go to number 5 now. So for number 5, we want to look at the same side interior angles. So these ones have to add up to 180. So we'll need 66 to be right there. Okay, for number 5, we're looking at these alternate exterior angles. Neither of these angles is in between the parallel lines. They're both outside of the parallel lines. So we call those exterior, and they're on alternate sides of this transversal line. So we call them alternate exterior angles. All right, so the answer here would have just been 134. So again, remember that all we have to do is either realize the numbers add up to 180 or they're equal. And if they don't look equal, you probably shouldn't make them be equal, right? These two angles don't, this one is obtuse and this one is acute. So these are going to be angles that add up to 180. So develop that sense of intuition, because that's really all we're checking, is that you don't use the wrong relationship. For number 8, we have vertical angles here. So we should get 75. For number 9, we have corresponding angles. So these two have to be equal if those lines are parallel. So that means I have 100. For number 10, we finally have an equation that we can set up. So we can set up that 86 equals X plus 90. But that means X will have to be -4, right? Because 90 minus 4 makes 86. So this would be the way to do that problem. Let's do another one. So in this case, we have a vertical angle that we can set up. So here we would do an equation, and we would get, first off, marking our diagram, so doing our 1-second geometry right there. Okay, we have those marks. So now I know that I can write 13x equals 14x minus 1. Now if I take 13x from both sides, we're pretty close to being done. On this side I have 3, and on this side I have x minus 1. So the last step will just be to add 1 to both sides, and we get x equals 4. So again, set up the problems according to the relationship, right? It's all about this first step and you understanding that this is true just by looking at the picture, okay? That kind of means that you're paying attention in class and that you're not confused by the diagrams and the lines crossing each other. So number 12, again, you would set these two equal because these are alternate interior angles. So we would say 9x minus 3 is equal to 7x plus 11. And if you solve this problem, you should find that x equals 7. We could go plug that back in there and double check, right? Like 7 times 7 is 49, and 49 plus 11 is 60, okay? And 9 times 7 is 63, and 63 minus 3 makes 60. So it's possible to check your answers and make sure that you got the right value. Okay, number 13. In this case, these two angles have to be equal because they're corresponding angles. So if 10x equals 50, then that means x must be 5 degrees, right? We gotta have 5. All right, so now we're looking at 14, and this was about congruent triangles. So we were basically just learning how to label that one triangle was congruent to another one, and we've done this a few different ways. Sometimes it could be more confusing than others because sometimes the angles are not labeled, sometimes they are. So if you don't know exactly how many marks to put, it can be a little frustrating. Okay, so the first thing I usually tell people is start off by writing one of the triangles. All right, we'll start off by calling this one the red one, and I'll call this one the blue triangle. Okay, I just have to name the red triangle some kind of way. All right, let's call it so UVW. Okay, just for this time, we could call it lots of different names, but for now we'll call it that. Okay, also happens to be in alphabetical order, so we like that order too. All right, so now notice that I see that U has 1 mark. Okay, so now I can't just write any letters. I have to be sure that I do this in the right order. U and W both have 1 mark, so that means W will be the first letter in the blue triangle. Should probably color that blue too. So now we look at the second letter. V is the second letter with 2 marks, and the letter with 2 marks in the blue triangle is B. So that will go next. Then we see that W has 3 dots, and W is the last letter. So the last letter in this triangle also has 3 lines, so I have to put C right there. Okay, so this statement indicates that those 2 triangles are congruent. All right. One thing that we could also do to make sure that we have them correctly in the right order is I want you to see that U is over here, and U is opposite from this angle. If I draw an arrow, I can see U is right across from this side with the 2 marks. Okay. Notice that W is also across from the one with the 2 marks. Okay. If I look at V, V is across from the side that has 3 marks. Notice that B is also right across from the side with 3 marks, okay? W is across from the side that has only 1 mark, and C is across from the side that has only 1 mark also. So this relationship is going to be something that is consistent. You'll always see that there with these kind of problems, all right? So here we go. The next thing is going to be a problem about, this one you guys should try on your own right now. So pause it, try to write the statement again, match up your letters correctly. Okay, I'm going to reveal the answer, so please make sure you have something done. And the answer is triangle FGH and triangle FGD. I understand there might be more than one answer, and the only thing that would be different would be the order of these letters, but F would still match up with F, G has to match up with G, and H has to match up with D in this case for this to be true. Okay, now we're going to talk about how to mark up the sides of the shape, and then we'll conclude the video. So for this problem, we understand that A and ABC will represent the red triangle, and then BAM is going to represent the blue triangle. So the first thing that we notice is that A is the first letter in the red triangle, and B is the first letter in the blue triangle. So that means that A in the red triangle must be equal to B in the blue triangle. Alright, but that's going to flip around for the next one because it looks like B is the second one in the red triangle. So that's going to be equal to the second letter in the blue triangle also. So the second letter in the blue triangle is A. So that means that A is going to be the one that gets 2 marks. Okay, so B in the red triangle, right? B in the red triangle is equal to A in the blue triangle. So now what we're going to do is look at the last one. Well, we actually don't have too much to choose from, right? There's only 2 angles left, and we've already used 1 mark and 2 arcs. So now we'll use 3. Okay, so this angle is equal to this one. Okay, so luckily we marked the angles, but now we didn't mark the sides, right? So that's the part that we have to label now. Okay, well we should notice there's a common side, right? This side is in both of them. So we can mark that one right now. Okay, so notice that AB and BA are the first 2 letters. What are the last 2 letters? The last 2 letters are BC and AM. So that means that BC must be equal to AM. Okay, now we get the first letter and the last letter, but that's AC. And the first and last letter here are B and M, so that also gets 3. So now this problem would be done because we marked the angles and the 3 sides of each of these. So this is the way that we finish that problem. Okay, so you can pause it and rewind if you want to look at that again. But I'm going to give you a chance to do number 17 on your own, and we'll see if you can get this one. So pause it, and I'll reveal the answer in a second. Okay, don't forget to pause it and try it. And the answer is right here. Okay, so good luck reviewing all of this material. You guys got more than enough stuff now. We've got almost everything done. The next video will be the last one on congruent triangles. All right, I wish you guys luck.